Money flows like power through this vein. Frac put his ass to work, make it pay. Killing dreams in a high-tech LA.
All right, dude, we've got to start this off. Someone was stalking me online.
As they do.
As they do. Found Chuck Yates needs a wife and has decided you're the single funniest person on the planet.
All because of, I don't even remember who wrote that. Was that Bossel or was that you, Jacob?
No, I actually had Googled ancient Roman torture methods. So here's what we're going to do. Assuming you're okay with it, I'm going to have Jacob just cut a few of your scenes
right
because that was so good.
Man, we have to do something about Chut. He's out of control. What do we do?
We could kill him. Maybe run him over with a truck and make him drown in his own blood.
No, we can't do that. Chuck's podcast is our most valuable asset.
What if we sewed him into the interior of a dead donkey so that only his head was exposed? I mean, we could strip him naked, cover him in honey, stuffed him into like a large basket, and sealed him in there with like an active beehive.
Dude, what are you talking about?
Maybe we could have him trampled by a pack of elephants, or eaten by a hungry pack of rats, or like a good old-fashioned crucifixion might be nice.
Yeah, I appreciate the props from her, but I also had nothing to do with any of it. I just said some lines. I didn't even look at the camera. I'm just looking at my monitor.
Oh, it was the best.
Literally reading the lines off of my computer the whole time.
Oh my God, it was so good. Now, when we're out talking to people about AI, we always say our data scientist is a former frac engineer. Is that actually true?
Yeah.
I've been meaning to check that. So tell me your background. I'm not sure we've ever done this.
Yeah. So I was a mechanical engineer for undergrad. And the summer before I graduated, I got an internship, my first oil field exposure, but I got an internship working for a small operator as a production intern down in the booming metropolis of Smackover, Arkansas, where I lived in a trailer.
Is that near El Dorado?
That's right outside El Dorado. Yeah.
Okay. I've been there.
Smackover field. So lived in a trailer, lived across the yard all summer in literally one stoplight. The bank closes at 4:30. We got off at 4, so we had 30 minutes to go put our checks in the bank and whole very, very small town kind of deal. So then when I graduated, I knew I wanted to get into the industry and started as a frac engineer for CUD up in the Fayetteville back when people were still doing stuff in the Fayetteville. That ages me quite a bit, but so then did that for a little bit, moved to Houston, did technical sales and support for frac jobs from Houston for a couple different companies, and then got into the gauge side of things, surface and downhole data.
And, I'm usually, for a lot of my existence around Collide / Digital Wildcatters, I was asleep on the couch. How did Collin actually find you?
No, I've known Collin since, I think I found him on LinkedIn back in like 18 or 19. And there was I think it was one of the Urtex or Doug's in Dallas. And we were up there. He made a post on LinkedIn that they were going to be there. I was like, hey man, we should just grab drinks or meet up or whatever. I'm going to be out there because, what he was trying to do sounded really cool and I thought was really needed at the time. And so the night that we met, we ended up, me, him, Jake, Kevin Satterfield, shout out to Kevin. We went out. I think we ended up, it was like Kevin broke his arm he broke his elbow on a Razor, one of the electric scooters. We were all cruising around and he completely ate it.
Grain alcohol involved in this?
There was definitely some alcohol involved. Well, and that's how I knew.
The statute of limitations of passed.
Yeah. That's how I knew it was definitely broken because he was many whiskeys deep at like 2 or 3 in the morning. He's like, man, it still really hurts. Like, it's probably broken. Anyway, we ended up at like Waffle House or IHOP at 4 a.m. I was like, these guys are pretty cool. And so we've been friends ever since. I was originally a client of DW doing different marketing stuff and then came into as a consultant initially. I had started my own kind of consulting data stuff. And anyway, that very quickly turned into a full-time thing. So I just saw on my Slack that I've been here for over 3 years now. So it's crazy. It's been a crazy 3 years.
It is crazy. So I'm glad I'm not lying when I'm out talking to people about you. You really are a frac engineer. So the thing we get when we're out talking to people, and one of the famous lines that we use is you can't deploy AI into a banker's box. So you actually have to get data into a digital usable type format. And I think that actually is where things need to start.
Yeah, well, and that's the thing too, is like even once you get it into a digital format, right? It's like that use case or that client we're doing the POC for now, right? It goes back 40 years, right? There's data, handwritten notes on these production or drilling reports from the 80s, right? And so it's like, just because it's digital still doesn't necessarily mean that you can do stuff with it. If, it's like, if you can't read the PDF yourself while you're looking at it and it's in this like script cursive, probably not a good candidate to be, because it's just not going to be able to pull it. But if you can read the handwriting, there's a very high likelihood that we can extract that. And so it's crazy because you're literally talking about decades.
And I couldn't say that 3 months ago.
No.
Yeah.
I mean, you're literally talking about decades worth of operational know-how and well-specific, field-specific notes. We always talk about the great crew change and the knowledge retention and stuff. And it's like, those are like, at least historically speaking, that's where a lot of that knowledge was in the actual documents itself, right? And so being able to expose that data to clients that literally didn't know what was in those boxes to begin with, now they can search through the entire thing with a few mouse clicks is pretty cool.
And so, okay, so I'm oil and gas company client guy. I have banker boxes full of stuff, and you've kind of talked me into I need to come modern and join the real world. What am I thinking? What am I doing? What are issues?
Well, no. So, I mean, that's the other thing too, is it's like, whether you do it now or in 5 years or in 10 years, you're going to have to do it at some point. You're going to have to digitize those files if you want to use them. Otherwise, just throw them in the trash or sell them to somebody, like, at the end of the day, really, right? And so the big thing, one, you need someone who, scanning them is one part of it. Being able to actually know, like, label each file or each document generally correctly is another big one. For this client, we partnered with Caso Land. Shout out to Scott and those guys. They did all the scanning, and not only the scanning, but they actually catalog them and name them and put them in files and folders and group them by asset. And it's much easier to deal with and manage that way when you have a general idea of what the document is than PDF 1, PDF 2, PDF 3. And it's just like, well, who knows? Because I've also seen other clients where it's like, they kind of did it in-house and they just took every file for the one asset and scanned it into one PDF. It's like, that's terrible. It's not a great, because it's a bunch of data in one file. And, ideally you'd have that broken out into each file. Each document has its own file type thing, because the big thing with the language models, it all boils down to a data problem, right? And so understanding the metadata about the document, or if it's this type of document, like take a post-job report, since we were talking about frac. In a post-job report, I know that there's going to be totals for every single frac stage for my chemicals, my proppant, my average pressures, my average rates, my mins and maxes, and all of that stuff. And so it's like, right now, you get the typical workflow is someone gets that post-job report in a PDF, and then they go manually enter that data into WellView or some database. It's like, in the future, there's no reason a human has to do that at all. You can just extract the data from the report and push it to where it needs to go. Also, it's in your language model as well, so it's all there and available. And so being able to understand what type of document you're looking at, it allows us to get even better answers on the back end, so that, if we need to extract additional data explicitly, we can. So like contract dedications is another one, right? You've got all these contracts and they're related to wells, but they're related by the lease or by the section township range. They're not related explicitly to the well. So the guys on the land and contract side have to go through contract by contract, find that dedications table, pull out the section township range or the lease name or whatever, and then go find all the wells that are actually within that. And then they know that, okay, that's the contract for just this bucket of wells. Well, that takes a lot of time for a person to do by hand. Whereas with a language model,
that's like literally conference room table opening to Exhibit A, because Exhibit A is always dedicated acreage under a marketing agreement.
Yeah. And so being able to do that just with a computer, okay, it's this type of file, go extract this table. Then from that extraction, go and find all the wells that are in that lease or within that geospace. We can do automatically now, which is pretty cool.
Because when I'm out there talking to people, what I always say is the magic is in our data pipelines. You have to have the domain experience so that you can chunk stuff, embed stuff, slap metadata on it. And somebody today goes, "What does that mean, Chuck?" And I said, "I don't know. I'm going to have John on the podcast in just a few minutes. Tell me what that actually means, John."
No, so I would say again, going back to the data problem, right? Like documents, some data has relationships, some doesn't, right? So the contract example, right? Each contract relates to wells, but via a lease. And so you have to understand that kind of hierarchy of, okay, you've got your leases, and then within a lease, we can have pads, and then within a pad, we have multiple wells, and so on and so forth. And so having that type of understanding allows you to either extract metadata from the document or generate your own metadata about the document that allows you to continue to give better answers, right? So for example, if you're the client and you want to know what wells the contract applies to, well, traditionally you'd have to go physically look all of that up. Well, if I can do what I just said and say, okay, I'm going to pull out the dedications table, and then I'm going to go find all the wells that are related or that are within that lease. Now I can add those wells or the API numbers or whatever as metadata to that contract, so that when someone asks, hey, what wells are related to this contract? Hey, here's the relationship from this contract to the wells that are related to it directly. And so it's all data on the back end, right? Like these people think that you just dump everything in there and it magically gives you an answer. It'll give you an answer because that's what they're trained to do, not because it's the right answer. And so that's, in our experience, the most important part of your RAG and your pipeline for RAG is getting that metadata and those relationships structured and built into it in a way that when you ask a question, it understands, okay, it's asking about a lease, not a well, or it's asking about a well, not a lease. Or, if it's offshore, it's in this block versus this, there's all the nuances of the industry and stuff. And that's really where having domain expertise significantly, because you're essentially reverse engineering the answer based off of a question. A lot of the time you don't know what the question's going to be because you're not the client. And so you can take your best guesses, but understanding what those questions are going to be allows you to understand how to break the data down, what metadata you need, so that when they ask a question a certain way, it's available to be filtered or searched against so that you get the best answer ultimately.
So do this real quick, just in case mom's listening. What's RAG?
RAG is retrieval augmented generation. And so what RAG is just a different architecture for where you leverage an existing language model, but on top of your data. The way that we do it is we essentially say, if it isn't in this data set, tell the user I don't know. And so RAG allows you to kind of eliminate this concept of hallucinations by constraining the answers to your documentation. So the worst thing that it could do is cite the wrong source, but it's never going to make up something. So it could give you a bad answer, but it's a bad answer still grounded in the data that is yours. With a traditional language model, they're trained on a giant, it's like the best generalists.
And when you say a
in the
language
world.
model, you mean like ChatGPT,
Claude,
Grok,
Gemini, Grok, all of the big guys, right? So a RAG still uses a language model, but it just uses a language model to summarize the answer from the search that you performed. A lot of people get that confused. And so in a RAG, the last step is you basically pass the subsection of text. So this is what a chunk is. If I took a 100-page document and I broke it into 100 chunks, that would be chunking it by page. So each page is just literally, here's my giant block of text from that page, or tables, or whatever else is in that document. And so the chunks just allow you to narrow down the context of the answer depending on what type of questions and answers you're going to have. But ultimately, you're doing a search based off your question. A language model is not involved at this point. You get you search across all these chunks, so all the parts of every document that you have in the RAG. It gives you the top K, which is a variable. So let's just say 5. So it'll give you the top 5 best answers or chunks that it found within the search. And then it gives those to the language model. and says, basically summarize this information that I'm giving you. Don't use anything else. Don't use your training data. Don't use anything else other than what I'm giving you to generate an answer. And so if we don't pass it anything, it knows, and it says, okay, well, we don't have access to that information. So it's not going to tell you a lie, whereas a traditional language model is built to give an answer, not the right answer, not the best answer, an answer. And so that's why you see it when it makes a mistake. And it's like, oh, you're right. You're absolutely right. You're so right. You know, it does that every single time when you correct it, because it is trained to make the user, to give the user an answer, right? And so,
well, and I mean, I think ultimately, because I had the head of Intel on the AI for Intel on the podcast about 1.5 years ago, and we were talking about RAG versus the foundational models. And back then, he was like, half the world thinks foundational models will ultimately solve it all. They'll get so good that ChatGPT will just give you the answer. And then he also said, but equally smart people in the other half of the world think you need RAG architecture for that context. And I've come to believe, and I think the world's there too, is ultimately you need that RAG, one, for the precision of the answer, like you're saying, but two, at the end of the day, cost.
Yeah.
If I am searching just this database, that's a lot cheaper than, hey, go search the whole internet, you know, and those 3 websites over in Sri Lanka.
Right.
You know,
that's another big point here is that,
and costs are going to matter at some point.
yeah. No, that's very, very valid, right? Like you're already starting to see some of the AI tools are changing their pricing models, or they're upping the price, or even GPT-5, like with it has this auto thinking feature where it intelligently routes your question to the best model it thinks for the best answer. But then I've seen a bunch of people publishing data on this, and it's like the output, you know, the number of tokens, which is ultimately how you get charged for these things with the new models.
That's
are like,
the gift card, basically.
Right, are like 2 to 3 times the amount of what they were with the last iteration. And so it's like they're basically inherently forcing users to use more tokens so that they make more money. But with, you know, another on the cost side with RAG versus language models have a cutoff date. The traditional foundational models have a cutoff date, right? So because they have to be trained, it's not this dynamic thing where you can just keep adding data to it and it magically works the minute you add it to it. With a RAG, the beauty of RAG, and one of the main reasons we went with RAG for this solution, is because it can be this living thing where I point it at a folder or a group of folders or an entire directory of data. And anytime a file gets added to that, I can run it through my pipeline, index it, and it's ready and available for search within minutes. Whereas a foundational model, it would take months for you to train it to the point to add a new data set. And so those are the big differences there. There's lots of really cool stuff and a lot of very valuable things from large language models, foundational models specifically. Coding is one of them. But getting to the depth of, you know, my company's specific data and the way that we phrase things, the verbiage that we use, all of that stuff, that's like a foundational model is never going to get to that level of specificity, at least unless someone just explicitly focuses on that for the industry. And I'm not saying that that won't happen, but it's still, you know, a foundational model is trying to be a generalist in a topic or multiple topics, right? It can go deep in certain topics, right? Like they've got it passing the bar and, you know, certain medical exams and stuff, but it still doesn't have the logic. Like they have thinking modes and they have this logic tree and stuff that they go through, but there's been a bunch of studies also that show that the logic starts to break after it gets 1 or 2 steps deep. And so it's not logic like you and I have. So a foundational model will have all of the knowledge in the world, but it's still like a toddler in understanding what it actually means. It doesn't have the understanding. It just has the data. And so that's a big piece of it.
So go back to data, because I want to make this point, and I'm going to say this as a statement, but it's obviously a question. I think one of the things you were basically saying is, at the end of the day, you're chunking, embedding, slapping metadata on the data as it's ingested in such a way that a vectorized database can understand relationships between stuff. And I think ultimately the promise of AI search is great. I mean, it's nice not to waste time, but ultimately it's automating a workflow.
Yeah.
And I think you almost have to start here so that, and let's go back to the marketing contracts. We may have marketing contracts that are pegged to CPI. So we need to go out and hit CPI, and my database has to know those relationships to be able to create that workflow. Am I right on that?
Yeah. It has to know the database. It has to know what's in the database, the types of fields, the structure, all the relationships, all of that stuff. And so that to me is one of the biggest like promises of a language model. Is traditionally we have either raw data or what I call contextualized data, so reports, some kind of text data. And typically we don't have them in the same place, right? So it's like an engineer is looking at the raw data, they're looking at it in a dashboard, on a Spotfire chart, whatever. But then it's not till after the job's done that the actual post-job report comes in that has all the details of like, okay, this is what we did. Here's, the notes and handwritten stuff or input notes from the guys in the field that contextualize the numerical data. And so being able to have all of that in one place in a language model really makes things rather interesting, because you can now blend your internal data sets with the numerical data sets that you also have, instead of them traditionally being kind of siloed away from each other. It also allows you to pull in external data like CPI or crude prices or stock price, whatever, right? There's so many APIs out there to pull data into different places. And that's what MCP basically is a way for you to get data from an API using a language model so that the language model can ingest it and use it and understand it and things like that. So it's really exciting from that perspective, just because traditionally our industry has been so siloed from a data perspective that it slows so much stuff down, right? Like someone in accounting needs some specific thing from an engineer, and the engineer doesn't have time to get it, but the data's in there. And so if you just had a tool that allowed the person in accounting to search for the answer like a RAG, they get that without having to ask anybody or, wait.
And then also the being able to automate that. I know the accountant on the 17th needs to know this number, and bop, it just shows up.
Yep.
Without even having to ask.
Or even
for
like
it.
the exceptions of workflows, right? Like a lot of in the regulatory workflow that we're doing with the G10s and the W10s, right? It's pretty straightforward. You're just looking at the last production test for each well and you're reporting that. Well, a lot of the times there aren't, there are wells where they haven't done a production test in the last 6 months, and they need to, but they don't realize that they haven't done one until after they start filling out this report. Well, now you dump your notice in from the Railroad Commission, and it runs and it pulls it, and it will clearly show you, okay, hey, here's the wells that you've got data for that well test. Here's the wells that are missing well tests. So go get some well tests before this report or this notice is due to the Railroad Commission. Otherwise, you're going to get fined. And so it's like those things would have been found out last minute, because it takes them hours to do those workflows just because of how they're kind of set up. But now you can run that in literally less than 30 seconds and have direct marching orders for everyone on your team of, okay, here's the wells that we've got the data for. Here's the wells that are missing data. Now we need to go dispatch our guys in the field to run some well tests before this date so that we can get this submitted and everybody's happy and we don't get fined. There's just so much of that, that we don't even know that it exists a lot of the times, but you uncover it as you go through these workflows.
We will not be ignorance is
Yeah.
bliss going
Yeah.
forward with. So let's go back to data. So I show up with my banker's boxes. You're telling me I need to digitize it. We're going to scan. We're going to figure out how to do best practices in terms of tagging what it is, et cetera. How do I deal with this problem? We were talking to one company, and I'll get this somewhat wrong. I think they said they had 39 terabytes worth of data on their system. 29 of the terabytes were duplicates.
Mm-hmm.
And that makes sense, right? You download something, you sit there and mess with it, you store it on your hard drive, you don't put it back on the system.
Yep.
All that. How do we deal with that problem?
Yeah, there's some programmatic ways that we can deal with that on the back end. I won't get into the it's not that much of a secret sauce by any means, but there's ways that you can essentially identify how unique a document is at a text level, and then as you ingest, you can compare that with what you've got in your index and see if it matches. And if it matches, then you just don't index it.
I mean, we can do something. I mean, because AI can really help on this process as opposed to, I mean, 5 years ago, you're having to do that manually.
Potentially. Yeah, there's some hacky ways to do that without having to have a person involved, fortunately. So that's, I mean, that's a lot of what we're focused on is like, you know, Collin is a big, proponent of doing things that don't scale, right? But you get to a point with software where, especially at the enterprise level, you've got to make it scalable in some form or fashion and stuff. And so we'll always take on projects that are new, or, you know, people are like, oh, there's no way you can do that. But the main point of that is not only can you do it, but can you do it in a way that it's enterprise and production code worthy. And so that's another big, you know, that's a difference in me writing a script that I just run locally on my laptop versus me writing a full-blown app that has, you know, Entra integration and SSO and all the security and the permissions and management of the users and all the other stuff. And so I'd say that's one of the big things there is like, you've got to understand that there's a give and take always. And so most things are feasible. It just depends on how much money and time you're going to spend on it.
If it's a finance change, we ought to take Chuck's file over John's file. If it's a frac job, we ought to take John's file over Chuck's file. Okay, yeah, I kind of get it. What else do people need to be thinking about with data?
Yeah, I think another one that just generally speaking, people are starting to look at, but as someone who's sat through just hours and hours, probably days or weeks of, you know, after action AAR meetings, or like we, you know, on the operations and engineering side, we'll do these meetings where, you know, something bad or good happened. And then we all sit down and we review what went well, what went bad, why, all of this stuff. And people spend, I mean, you spend lots of time putting those presentations together, getting all the data together and stuff. But the actual knowledge and the value from those conversations is spoken, right? And so like, putting that PDF in there is only going to capture a fraction, or that slide deck in there is only going to capture a fraction of what was actually discussed and the knowledge that was actually shared in that meeting. So having just an iPhone sitting there recording the meeting, you can now take that data and transcribe it. And now you actually have, you know, the industry, company, domain expertise knowledge stored forever.
And so I think, searchable.
Yes, searchable, discoverable, there for every person from there to in the future forever, you know, potentially to have access to. And I think that's a really interesting thing in our industry, given the whole crew change and all that stuff. I'm very personally super optimistic that LLMs and RAG will help with that. Also terrified as an engineer that, like, you know, you can't find service companies now that can run a gelled job. Like, that's all we did when I started in the field was most things were cross-linked gelled. And so it's like, you can't find companies that have hydration units anymore, just the equipment, no less the people to do those jobs. And so like, that terrifies me that we're going to have a whole nother like generation that comes through the industry that's going to have to relearn stuff that guys 20, 30 years ago already knew, but now we've retired them.
Well, you will appreciate this. So we were out at ProFrac yesterday because they were doing kind of exhibit day, showing all their stuff, and they've got a sand company, and they had different grades of sand. And so I went up and I was like, Jacob, roll the camera on me. I go, engineers used to tell me I need very coarse sand to cut a big path through the rock so that the natural gas and the oil could flow through to create permeability. And then some engineer who must have been stoned or something said, dude, let's put some talcum powder down there and see what happens. And lo and behold, it worked a lot better.
Yeah.
Two things. One, mad respect for the engineer to actually experiment, measure, test it. But the other half is, you're totally full of shit. You didn't know what you were talking about back then.
Yeah. No, I don't know this definitively, but I'm adamant that happened because 100 mesh is a byproduct of 3050 and 4070 proppant when you're mining it. And EOG had their own sand mine in South Texas where they were mining 3050 and 4070 because that's what everybody was using. Well, if you are sitting there and the pile of 100 mesh that you've got just continues to get bigger because it's a byproduct of these other two products that you're actually using, at some point I feel like someone was just like, hey, it's free. We've got it sitting there. Let's see what happens.
Don't cost nothing.
Literally. And
because that's what an ops engineer would do.
Yeah.
They don't care. They don't go talk to Reservoir and say, hey, what are my analogy wells based on?
yeah,
No.
I also think we as an industry figured out, and this was after a long time of being, same deal, right? Like I can't tell you how many lunch and learns, webinars I sat through from, Saint-Gobain and all the ceramic proppant companies preaching about how you needed crush strength because, the reservoir pressures were too high and you would put sand down there and it would just crush itself.
Right.
And it's like, come to find out that doesn't matter at all. Because any sand that we put down there is infinitely more permeable than the shale. And at the end of the day, that's what ultimately matters. And so, 100 mesh versus 3050 are both ultimately super highways compared to what the shale is from a perm perspective. And so it doesn't really matter. But I think a lot of it is more about, because I saw a article this week from Exxon talking about, now they're pumping, coke ash. So another byproduct of power gen or coal plants that they may or may not probably have sitting around as a waste that's free that they need to get rid of anyway. And someone was like, hey, maybe we add this to a frac job. I don't know if that's how it happened or not, but they're showing, anywhere from 5 to 15% production increase by adding that. And it's because it's lighter than traditional 100 mesh, right? So it actually gets in places where it wouldn't be able to get or settle, at least generally speaking. That's the concept. I haven't looked at any of that data, but yeah, it's fascinating stuff.
I don't know. It was fun out there. So, okay. So, what else do we need to be thinking about when we're thinking about data? And what I might do is say, what are we potentially going to look back 5 years from now and go, oh my gosh, I wish we had done this.
So even if you don't immediately use them today, just digitizing your paper documents, again, to me, it's almost like a piece of tech debt on the, programming software side. It's there. It doesn't go away no matter how long you wait. It's just lurking over you. And so, if you can build that in your budget, you're gonna have to build it into your budget at some point.
Right.
Or just get rid of it, throw it away.
Yeah, there's only liability.
Right.
Yeah.
At some point it's just literally taking up space. And so if you have any plans of trying to use that data, go ahead and at least get it organized, put into a digital format. Because the way things are going is that there's a very strong chance in the next year or two, you'll be able to leverage a lot more of that data than you would have in the past. In the past, you'd have to use OCR, you'd have to use these very finicky kind of very touchy techniques to get data out. And that's no longer the case. It's much easier to get data out of, PDFs people think are structured, but PDFs are just a dumpster fire it's just a dumpster where people throw any kind of data to, and so extracting the data from those is not easy by any means, but the tooling around that over the last year or two has gotten so good and it's only going to keep getting better. So,
well, and I want to be nuanced on how I say this because everybody's cloud bill is through the roof and they think it's expensive, but storage actually doesn't cost anything.
Right. Storage continues to get cheaper.
I mean, my brother has been mechanical integrity of hard drives since he graduated from Rice. He has kind of sat at the same office through compact computers. Yeah. Every once in a while, a supplier steals him away and he goes away for a year or two to get a raise and he comes back and now he's at HP or whatever it is these days. But I mean, it's ridiculous how much data. And the deal with AI is you can go search that data. Yeah. So, I mean, we're literally driving search costs to zero.
Yep.
I mean.
Yeah. I think the other big one is, and we see this all the time when we go into clients, there's always someone from the production, SCADA, IoT department that's like, I wanted to optimize my artificial lift or my ESPs or whatever. It's like a language model is explicitly built for language. It is not built for math. And, the way that ChatGPT does math now is it writes a Python script and then it executes the Python script because Python is actually good at math and built to do computations. And then it gives the answer back to the language model and that's how it does math. And so it's like, being able to see GPT do something and then assuming that is how everything can work like that is a bad way of looking at these things. I think, with numeric data, the the interesting thing with numeric data for language models is being able to query it, right? Connect to my production database and then let me ask questions about it as a non-technical person, not having to write SQL or know anything about databases, just being able to ask information about my database and getting that out. And I think being able to have that across a company, where all different departments can ask their questions of the same data sets and get their answers directly and immediately is like truly game changing for how quickly we're going to be able to do stuff in the future. Traditionally it's like, okay, that person has to go take their problem to someone in data or IT, and then that gets put in like a queue, right?
Right.
And they have to create a ticket, and then the person who's generating that, or once they get to the ticket, the person who's actually doing the work has to go call the person who put in the ticket to get all the details about exactly what they want. Then they have to go write the query. Then they write the query, and then they give them back the data. And then that could be a day, that could be weeks. And so it's like in the future, you just ask the question and you get your answer and just keep moving. So I think that's another really, it's just an education piece. Language models are statistical models that predict the next best word or set of words, right? They have nothing to do with numbers. And so trying to use them, it's a tool in a toolbox, right? Machine learning models are the same thing. Machine learning models are built for that. They're built for feeding in a bunch of historic time series numeric data to predict what it's going to do in the future. Like that's literally what they're built for. So if you're looking for those types of things, that's a machine learning problem, not a language model problem. If you want to query your data and just ask questions about it to find answers in a database, that's a great language model use case. But I think just understanding how they work at kind of a base level and understanding the limitations of these things is really important, because if you listen or you're watching any of the GPT, Claude, Gemini battle in public or in marketing, they do everything for everybody, right? Like that's also part of the problem with tech is they overpromise. They promise the world, they make these demos explicit for this one very specific thing. And then they spent God knows how much time doing that just so they could show a demo. And then everyone's like, oh, well, now they can all do this. And it's like, nah, not necessarily, right?
We always overestimate technology in the short term and then underestimate it in the long term.
Completely agree.
Yeah. I mean, because the internet now is ubiquitous and like literally embedded everywhere. It's in our phone, it's in our watch, it's and you almost don't even know it's there.
Yeah.
And I think Altman's right. He was on Theo Vaughn of all places talking about
I need to go watch that actually.
Well, two interesting things he said about AI is one, it's just going to be embedded everywhere and you won't even notice it. And my running joke whenever I talk about it is, when you leave the bar and you drive through Taco Bell on the way home, your toilet's going to know to warm the seat on the way home. I mean, it's going to get to that point where it's going to be embedded in everything. The other thing he said that's really interesting that I'll get you to comment on, maybe here's what we'll close on, is Sam Altman thinks that your searches into your AI models ought to be protected like attorney-client privilege. They ought to be private because now they're not. If the government shows up at OpenAI and says, I want to see the searches somebody ran, they have to turn it over.
Yeah, and I think that got even, I guess, less restrictive would be the way to say that within the last couple of weeks, because there was a lawsuit. I guess it was I don't know if it was class action or not, but anyway, yes, that's a terrifying thing, because right now, they can get your entire chat history, and it's still the very early days of this thing, right? So people who are in there just messing around could potentially be flagged as doing something bad when they're just trying, there's
God knows I don't want to see my Reddit, my Reddit queries.
So, but I do agree with that it is, it's information that you're using in the privacy in your own private place. At least people think that it's in their own private place. It's happening in OpenAI's cloud,
right,
or wherever they're hosting their stuff. But ultimately, understanding the privacy around these models and what access they have and the history, how long they store your data, all of that stuff is incredibly important, especially when you're talking about enterprise level stuff, because no one wants their data. No one wants their next month's earnings calls to be accidentally exposed via ChatGPT.
Right.
So that's no, but I do believe the best implementations of any kind of AI are almost invisible to the user, right? Like there's all kinds of stuff on your phone happening. Like Apple's really good about that, generally speaking, right? Like with the new iOS, you can go in and search through your photos just with plain text, right? It's like there's a language, there's a vision model underneath the hood looking at all the photos and has already labeled all those photos on your phone. And so it's like, you didn't know, you had no clue, but the feature that you get is the search.
Right.
But the model is running all the time. And so that to me is like the epitome of a beautiful kind of implementation of AI, because the user only sees the benefit. They get none of the frustration up front.
And you don't have to be a prompt expert.
Right. You don't have to be an expert at all. You just type in,
I want to see a flower.
Yeah. Literally.
Yeah. Okay. I'll confess this. And, anytime we're out talking to clients, they'll always say, well, can you talk to this? Can you, talk to this? And I always say, every time we've had to talk to something, John has been able to make that work. It's just what shade of red does John turn? And, when he's really red, he doesn't talk to me. He doesn't tell me how much of a problem it is. But so far, we've been able to talk to all the databases, all the other legacy software. So far, so good.
Yeah. No, I mean, I think that's the thing I'm most excited about with what we're doing, with what other people are doing in the language model space, is there is just still so much siloed data in this industry. Like one client we're working with has recently moved to the cloud version of this software. And then because they're in the cloud version of the software, somehow they magically don't have API access to their data anymore. When that was like one of the biggest promises of cloud, is that you can now provide access to the data anywhere you need it. And so, but it's just a perfect microcosm of what the entire industry has been dealing with for the past 20 plus years, is software vendors that get you in and then cause an excessive amount of friction for you to do your job, even though you're the one paying them for the service. And so it's like, hey, if we can start
sales versus production,
if we can start integrating these things on the back end, then the world is our oyster as far as that goes with the energy industry. But there's still a ton of softwares out there that you can't, or they don't want you to, or you have to pay more to get access to just the API, dumb little stuff. And you're paying tens or hundreds of $1,000s a year for this. And at the end of the day, it's still your data. That's the craziest part about all this to me.
Thank you, sir. May I have another?
Yeah. It's the operator's data. It's your data. But if you're buying software from vendors that don't allow you to access it under very explicit conditions, then there's a problem with that. Like, I can access my freaking washing machine, my dishwasher on my phone. But, if I'm a production engineer and an operator, I have to be on my company's specific network or on a VPN, and then have to have all this extra stuff to go into it, which part of that's security, and that is good and valid. But from the software perspective, the software companies that are going to get ahead are the ones that are going to allow people to use their data from your software where they want to ultimately end up using it. And so I think the industry historically has the incumbents have rested on their laurels because they got in first and fast, and they just didn't have to do development or add these things that the users wanted. But now that there's more and more software coming out, tech has continued to infiltrate the industry. That's changing.
Well, and I've totally drunk the Kool-Aid, because when you use a GPT interface and you use natural language, it's just intuitive.
Yeah.
And a lot of the switching cost, I think, on legacy software was just, I know how to use this, so.
For sure. Well, and that's the potential cool part, I think, in the short term, is that language models layer on top of those softwares, right? So like, you're not having to change user behavior in the software that they're using every day. It's just that data is now connected to all of the other data via a chat interface.
Right.
And so over time, I think there's no telling what the software market looks like in 5-10 years because of how this changes things. Because I do think it will significantly change a lot of the structures of the kind of foundational software tools that we use. But
right. The only key is it needs to change where we're rich. That's
the plan,
We've
Chuck.
been through too much. John, you were cool to come on, man.
Yeah, man. Absolutely. Appreciate it.